today we'll build a basic RAG application with multi-source. So here we will be using three sources. First one, first one would be the Wikipedia. The second one would be the a custom PDF, and the third one would be the website. So first will be your Wikipedia, and the second one would be the, let me do this, Wikipedia. Second one would be your custom PDF. It can be any PDF. So for this tutorial we will be using the a history class book, 10th class book. Okay, so it will be better. Then for the third one would be a particular website. So for the website we are choosing the Python documentation, and it will be answering on the basis of the documentation which is present in the website. Okay, so let's start. So first of all, for RAG, let me explain what is RAG is. So RAG is a retrieval augmented generation. So what it will does is it retrieves the data from these particular data sources, and after that retrieval, what it does is it takes the context from the retrieved data from these particular sources and the prompt and the input, and then it passes it to the LLM. After that, the LLM gives the output, and we will generate the show the output here. So if I'll give you one basic demo how it works is, so see, here it is. I can say we are using, let's say, what is object in Python. So what it does is it will query the documentation which is here. But you will see in Python documentation. So what it will do is it will query this particular thing, and from there it will search the object where the object is being written, and it will give us the output. So it will pass into the LLM, and then it will give us the output. So it is still running. So it will take some time to run it. Yes, yeah. So in Python, an object is an instance class. So based upon the website description, it is. So apart from that, I have one PDF which is a 10th class history PDF. So what if I can say, let's say, India and the Great Depression. So what it describes is what was the situation of India during the Great Depression in 1929. Okay, so if I write query, what was the situation of India during for 10th class. So what it will do is it will try to search first the website. If it will not find any data in the website, then it will search into the PDF, and if it finds the answer in the PDF, it will give the answer according to PDF here. Okay, so it is something like that, exporter of that something is written, so it will try to give the answer according to that. Okay, so this is the basic. So it is just that. Now let me give you the brief introduction about how it works. Okay, so to that, what the first challenge is, to convert the words into the numbers. So what it can do is, what it does is basically, so there is a word called battle here. Okay, so what it will does, this is called features, and these are the words. So it will try to rate the word based upon the features. So let's say the battalion authority has no combination here, so like no relation basically. So it will try to give around 0. So if the relation is tends to positive side, then it will try to give it will be the range between -1 to 1. It can be infinite, can be float decision and float as well. So if it has the relation, strong relation, then it tries to give positive side, and is strongly against, then it gives towards -1 side. So if for let's say for a gender, if we consider women as a +1 and man as a -1, then here we can see that gender king has a -1, and the man has also -1 here, and the queen is also 1. So since the woman is a positive side here. So similarly, if has tail as a feature, so if no relation is there, then it will be trying 0. So battle and has tail has no relation. Horse and has tail has a strong relation, that therefore it has 1. King has no relation tail, therefore it's 0. So what it will try to do is, based upon the features, it will try to rate the each words such that the meanings can be captured. So here, if I'll give you one more example, let's say, what is the same word? I have the shares of 5 shares of the apple, and second statement is I like apple. I like apple juice. So in the second statement, apple juice is like here is a fruit, and the first statement is it's about a company. So based upon the context, it derives the embeddings here. So similarly, like if let's say there is an like if I am talking about shares, so it will be there can be one feature called is company, and for this particular embeddings it is company. For the first statement, there can be a strong relation that can assign +1, and the second one it will be assigning it 0 as because it has the apple juice has no relation with the company. Is a company, so therefore it will be assigning 0 only. Okay, so similarly, so the benefit of doing this is we are first converting the numbers into the we are first converting the words into the numbers, and after that we can we can multiply, add, subtract, we can we can add different mathematical operations here. So if I'll give you one example. Okay, so for particular word, if I say king, so king has authority, yes, so strong relation, therefore we are assigning 1. King and event has no relation, therefore 0. King and tail has no relation, therefore 0. King is rich, therefore +1. And king assigning the man as -1, like negative side, and women as a positive side for gender. So so if it is gender neutral, let's say there is a pen, so it is gender neutral object, like no relation is there, therefore 0. And for king, we are assigning -1, therefore -1. Okay. Similarly, for man, man has comparatively less authority to king, so therefore we will be assigning more towards 0 side, but not exactly 0 because it has some relation there. And there can be as a after that man, there can be also slave. A word can be slave. So in that particular sense, a slave has no authority, right? So therefore it will be more of a negative side there. So therefore here king, man has a somewhat authority, therefore 0.2. And event and has tail has no relation with the man word, therefore 0 0. And rich, it is comparatively less rich to king, therefore 0.3. And if it is again there is a word with a slave word, then obviously he'll not be a rich, therefore he's a slave, right? So it will be more on the negative side. And gender is, since we are considering man as a -1, therefore -1 here. Similarly for women, if we take the embeddings here and we try to subtract. So what we can do is, let's say king minus man plus women. So logically what we are thinking is like, okay, there is a king, we take out the features of man from the king and we add the features of women. So what it will become? Logically, if it's say king minus man plus women, so logical answer would be queen, right? So similarly, we derive, so we -1 -0.2 plus 0.2 here, therefore +1. So what this authority, what we are getting, that this the object it will be pointing to, it has some like a great authority. Okay, so since event and has tail and will be zeros, basically it is not an animal which has tail and no relation with event. So in case of battle here, we are assigning as an event, so therefore we will be assigning towards positive one there side. So here, but since this particular after summation and subtraction, we are getting 0 0 here. And for the rich, so if we subtract 1 minus 0.3 plus 0.2, we'll get a 0.9, which means, okay, this object, what it is more rich compared to man and woman. So more of a, so what this embedding show is, this person has authority. Okay, no relation with event, no relation with tail, and it is a rich, and gender is a +1. So most like these embeddings will mostly try to give this towards women. So what it does, it will try to compare it with other vectors. So okay, so there are two words. Okay, so and two words it will try to compare. Okay, which word is matching? I'll show you in the next slide, which can be there. So okay, So this is a vector base. So what it will do is, okay, so it will this, I assume this is, it is as a query or a word. Okay, then there would be a database here. So it will try to search relate upon the database. So if I'll remove this, okay. So what it will do is it will try to search. So it will try. This is will be the query, and these will be the embeddings here. Okay, so let's say we are searching the embeddings of queen. Okay, we will be getting the embeddings, and we will try to see which embedding is most similar to this. So it will try to see, so like these parts are completely different and these parts are completely different, but these three are somewhat similar to this particular query. So what vector database do is, it takes the query, it converts into the embeddings which we have shown initially, and after converting them into embeddings, sorry, it will try to see the different embeddings present in the database. So what it will do is, during training, the whole text data will be converted into embeddings. So like initially, right now, initially I've shown you the PDF. So whole PDF has been converted into the embeddings. After that embeddings, whenever we try to search the query, it will see, okay, which particular query has been related to this particular data set. So for example, there is a paragraph, okay, which talks about the French Revolution in the history book of class 10. Okay, so if we search what is French Revolution in class 10, okay, so what it will do is, it will try to abstract the embeddings from that particular sentence, which will be the query here, and it will try to see how much similar particular context present in the database here. So if let's say this, if it finds some paragraph regarding this particular query, so it will retrieve that particular thing, and after retrieving, it will pass into the LLM along with your question. Okay, so since you are asking, okay, so this is the particular paragraph which has been written in the book, and this is a query that user has asked. Combine this using the prompt. You give me the answer. So it has the paragraph which is which in LLM terms we used to say is context. It has the context, it has the query, and it generates the output. So first of all, the question is how LLM generates the output. So during training, what it does is, let's say there is a paragraph of, let's say, 1,000 words, right? So what it will do is, it will take a window size. So if I'll show you the example of a window size as well. Okay, so let's say there was a king who lived in a village. Okay, let me zoom a little bit. Okay, so what it will do is, we have passed this whole particular context here. So it will try to mask one word. So let's say it has masked means it will try to hide. It will not give it during training. So what it will do is, it will put it like this there. So if considering window size as 5, so 1, 2, 3, 4, 5. So till 2, it will try to search. Okay, and what it will do is, it will give this input as there dash mask, which is will be there, a king who, and you have to predict what is the right word. So okay, if it will predict the right word, then it will give you a positive number, like positive, which is a loss. Here you see that it will give a less loss compared to if it predicts the wrong word, then it gives a higher loss. And during that particular loss, the objective is to reduce the loss. So what it will do is, it will pass through whole sentence, and it will add all the losses, and after that it will update its methods, and again it tries to predict. And so main objective is to decrease the loss here. Okay, so here in this case, it will take the window size of 5 words, and it will try to predict. Okay, so let's say initially it started predicting, and it predicts it just therefore there I a king who. So it predicted the word I, and the original word was. So since the distance is too much during this embedding, so it will give a higher loss. And the more the loss, like let's say, like in the next iteration, after changing something inside the black box, what we can say. So it predicts the word was. So in that particular scenario, the loss is 0 here. So like the overall loss during the whole sentence parsing, it will decreases. So similarly, after predicting this, let's say was, and what it will do is it will shift the window size and try to predict. So what would the window size would be? There was a okay. So this would be the window size for 5 words here. There was a dash who lived here. This would be the window size here. Now what it will do is take upon based upon this input as 4 words, it will try to predict the mask word. It if it predicts the right word, then the loss would be decreasing as it is predicting the right words. And if it is predicting wrong words, then it will add up the loss and the whole objective would become failure. Okay, so this is whole basic idea of how LLM works. Any LLM you talk about, ChatGPT or Llama or Pi or Mistral, any LLM. So what the main idea is to predict the next word based upon the nearby 2 to 3 words, depending upon the window size. So the more the window size, the more it try to capture the context of what kiski baat chal rahi hai basically. So if we are seeing a movie, so we need to understand the whole context. Okay, this is happening. So we don't focus on the exact scene, what is playing. We understand the whole context. Okay, so it's Avengers movie is playing, so we know okay, this is a hero-based film and this is a particular hero, something like that. So whole context should be there, right? Similarly, the more the window size, the more context it captures and try to predict the right word. So this is how a basic LLM works. So what the concept of RAG again from, if I'll tell you, it will extract the data which has been sources which is right now for this particular use case we are using PDF website and the Wikipedia. It will try to capture all the context. After capturing context, it will give the input to LLM along with your query and your prompt. So after using these particular things, it will complete the sentence. So it will give the first word, then based upon that word, it will try to like predict next words. Since during training it has been so perfect that it predicts the right words and it generates the whole sentence. So this is whole basic overview of embedding. So let's dive into the more of practical side of how to create that. Okay, so for this, if I'll share you the okay. Okay, so for this we have first of all the prerequisite as Anaconda. We need Anaconda. So this all has been uploaded to my GitHub repo, so you can search it with Shirish 7. I'll share the GitHub repo link as well. Okay. So what is the prerequisite? Prerequisite is first is Anaconda. We need Anaconda, so you need to have install this Anaconda from this particular website. Then VS Code. We will be coding into VS Code only. So in the VS Code we need 2 extensions: Jupyter extension and Python extension. So these 2 extensions are necessary for running the code. Then what we'll do is we'll create a new environment. So based upon this, I have already created the environment. So you can, this command has been already there in README, so you can copy paste this exact command, it will get you. Then after that you have to activate the environment. So see in the terminal, you can see from here you can activate your new terminal. So I have already activated the terminal. I have already run this command, and see here you can see that session. Okay, I'll zoom a little bit. Okay, already you can see session environment is there, right? So I have already activated that. Then what you have to do is you have to run this command. So what it contains is, it contains all the requirements. So these we will be building RAG on the LangChain here. So all the LangChain community, LangChain OpenAI, and with the LLM we are using is ChatGPT. So like the LLM name is GPT-3 model, GPT 3.5 Turbo. Okay. So and apart from that, for PDF reader we need PyPDF 2, and for scraping the website we need Beautiful Soup 4, and for Wikipedia, searching the Wikipedia, we need Wikipedia library. So what we'll have to do is we have to install this particular all the requirements here. So what I'll do is I'll copy this. Okay. So since I've already installed that, so therefore all this requirement are already satisfied. For your case, if you try to run this, it will say downloading and it will take some time to download whole the libraries. Okay. Then after that, you have to set up an environment .env variable in which you will be storing your API key of your GPT. You can use as well. You can also use Hugging Face. So I can show you where Hugging Face model can be. But you can also only use for that a limited models only with 7 billion models, which are not that efficient enough. But for learning phase, you can always do that. So what you have to do is uh, go to settings and access tokens. So it will, so here always where you will be having access tokens here. You can just copy these particular access token and use this particular thing. For this use case right now, we are using only the GPT 3.5. Okay, and let's start. So what I'll do is I'll create one IPNB file. Okay, so first of all, this .env file I've already saved my API key here. So what I'll do is I'll load this environment variable as an environment variable. So what I have to do is I have to use import OS here, and after that, okay, from .env import load env, and after that OS dot environment open AI open AI API key. So remember this should be always be the larger case. So okay, first of all let me select, but after doing this you have to select a kernel here. So I'll use select another kernel based upon our environment name. So our environment name is session environment. So I'll go to the Python environment and session environment, and it will take some time. Meanwhile I'll write the code. So see here it is installing IPY kernel and all, equal to OS. So let me show you how environment file would be looking like. I.env I am writing here so that it doesn't coincide. So what environment file would be looking like is I have stored a variable called OpenAI key equal to something like sk dot something you would be there, uh, like some would be there. So this is how environment variable should look like. Your OpenAI key equal to it has been stored in the variable, and this should be your API key. Okay, so should be there. So this is how environment variable look like here. So what you have to do is you have to call this particular variable in your working session. So os dot get environment open AI key. Since I have stored in this particular format, therefore I am using it. You can, like, what you have to do is you have to always call this the particular the variable which you have stored. Okay. So since it is installing, let us go ahead with another one. After using that, what you have to, okay, it has been done. Okay, there is. So here it can you can see that there is some issues. There can be some issues with Python as well. Therefore, it's not getting captured here. So let us try this. Meanwhile, what we can do is we can write some of the codes as well. Okay. So pip is there. Okay, here it is session environment. Okay. So since it's now it's you can see here it is already been loaded. Okay. I have now the API key has been loaded into the environment. So what I have to do is after that we will be doing is extracting the so before that we have three different sources here, right? So first one is the Wikipedia, the second one is the PDF, and the third one is the website here. So what to do is we will use this different sources here. So for extracting the data, Wikipedia. Okay. Give me a second. Okay. 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 Now what you have to do is first of all from LangChain community dot utilities import Wikipedia API wrapper. So what it do is it is a wrapper for API. So what it does is it uses the API of Wikipedia and try to search the all the Wikipedia data which is present in the database. So and after that we need a query as well to run the query of your whatever search what you're searching. So LangChain community dot tools import Wikipedia query run. So what it will do is it will run the query which will be suggesting. So it is just a kind of a wrapper you can see as well here. So after that, let's assign it to the variable called wiki here. Wikipedia API wrapper, and what we'll do is we will using top key results. So how many results you want. So what we'll do is whenever you will search the Wikipedia, there can be 3 to 4 websites here. So we don't need the top first one. So we will be assigning the top key results first to one here. Okay, and we don't need the whole document, right? We need some limited documents because there is token limit in the OpenAI as well. So what we'll do is we'll write a stop. Sorry, doc content characters. How many characters you want? So let's assign it 300. I guess 300 would be more, or let's 500. Okay. Then after that, after we have assigned the API wrapper, so what we'll do is it will search according to the API. Now we need to run the query as well. Okay. So we will using this Wikipedia query run, and in this we will assign our API wrapper. So let us assign this as wiki API, and we will use this as wiki. So what we'll do is we will using this wiki object to search the query. Okay, so it contains this. I'll say wiki contains the object of query. Okay, so this one is what now we have created a what you can say wireframe in which we will be passing the query and we'll getting the results. Okay, now let us create a new now, and after that we will extract the data from PDF and website. So the extraction of data from PDF and website is almost similar. So from PDF and website. For this, what we'll do is there is one thing or one already library present, which is called IPDF loader, and apart for PDFs, and for the website there is called already web-based loader is present. So we will be writing that. So for PDF, okay, from lang. Okay, so let us. I need a code here. From LangChain community dot document loaders. So these all comes into the document loaders. Import py PDF. So here you can see py PDF loader has already been there, and then another one is web-based loader. So what py PDF loader will do is it will use the py PDF library which you have already installed in requirement.txt, and for web-based loader it will try to use Beautiful Soup 4 to scrape the website. Okay. So the method for extracting PDF and the website would be almost similar. Okay, and after extracting whole data, what we'll do is we'll divide this into separate chunks. So we won't be passing a whole PDF. Let's say there is a PDF of 10 pages, so we won't be passing whole 10 pages. We will be dividing this into the chunks. So to do that, we will using from LangChain community dot not LangChain community, LangChain text splitters dot import. What we'll do is we need recursive text splitters. Okay, so what we'll do is it will split the characters. Okay, so let us load the document first. Docs equal to by PDF loader. So I'll copy this path. Copy path. This. Okay. By PDF loader. Here you can see that we have the path, and always make sure that you always use R here, since it is a it contains the folder path as well. So you have to be careful with that. So always use the R here. It will convert into the raw file. So it will ignore this backspace here. After taking this, we will be converting into the chunks. For chunks, recursive text data. So how the chunks you want. So what we will do is we will use a chunk size of 1024. So 1024 characters would be there, and chunk overlap is one more parameter. A chunk overlap, how much overlap you want. So you don't want only 1024 this particular text. You want some overlapping so that it takes the whole context here, right? So chunk size 1024 and chunk overlap equal to, let's say, 256. Okay, and by PDF load I have to use here. Let us see this PD splitted PDF. Okay, similarly we have to do for the website here. Web-based loader. I'll use this as a website so it contains all about scope, namespaces, something like that, classes and all. So we have given the path dot load web. Now after loading all these documents, we need to split it, right? Splitted web equal to, we have to use recursive text splitter. Again, same, I'll use this only. Okay, so it is text splitter. Okay, and splitted PDF text splitter dot from documents split documents, and again iterable. We will passing in docs, and here text splitter dot split documents will be passing as well. Okay, so let for simplicity case, I'll put this as a home. So let me explain you one more time here. So what we'll do is this would be converting chunks. Okay, then this particular PyPDF it will be loading the document, and after that loading we will be converting into the chunks again for PDF, and similarly for the website here. So what we'll do, it will after chunking the website, what we'll do is we have to save into the vector database. So which I have shown here, right? See, here it is a vector database are there. So assume that each particular image is a chunk of data set which we have already chunked. So see, these whole database data set will be there. Then we will be running a query and try to extract the related database, right? So let us run this. It will take some time. Okay, now what we have to do is we have to use a database. So what we'll do is we will be using FAISS. It is it is an open source created by Meta. So from LangChain community dot vector stores. You don't have to remember all these. It can be easily if you do search the Google search, simple Google search how we have FAISS vector store, how to load in LangChain. It will be already there. Import FAISS. Okay, so this is the vector store, and after that what it will do is it will store the vector store in your memory. So there are two different ways. One way is to store in the memory, but due to the large, if we are parsing a large documents, then the memory issue can be there. So to overcome this particular thing, but there is some database called PromaDB, something like that, which stores into the persist directories. What persist directories? Basically your hard drive and some SSD and all. So it will store all the particular embeddings into that particular thing. So right now we will be, for simplicity's sake, we will be only using this into the RAM only. So after that we need to use OpenAI embeddings from LangChain OpenAI import OpenAI embeddings. Okay, so we have imported all the vectors here. Now let's try to put into the database. So what we'll do is we'll create two database, one for the PDF, one for the website. So similarly in everything, we will be creating another tool for each tool. So whether to search PDF, whether to search website, whether to search Wikipedia, it will decide. So therefore we'll be creating two databases. So let's say TV of PDF is FAISS. Okay, after that then we will be passing into the splitted PDF here and OpenAI embeddings. For the web is similarly for the web, DB web FAISS splitted web OpenAI embeddings. So it will store into database. Then after that we need to retrieve as well. After saving that we need to retrieve as well. So to retrieve, we will be putting it as dbpdf dot as retriever, and we will be assigning into variable called retriever PDF. So it is just like a function which will retrieve the relative embeddings from the database. Okay, then retriever we will be naming as web db web dot as retriever. Okay, so what retriever PDF retriever web will do, it will try to retrieve the data related data from the document, relative embeddings from the database, which is a vector database here. Okay, so after that what we'll do is so what main objective is to see whether from where to fetch data. We need to give the power to LLM. So if we are talking about history, then our model should be knowing that okay, you have to search this particular PDF, or if we are talking about Python or documentation, then you have to search this particular documentation. So here what we'll do is we will be using we'll be creating a retrieval tool basically. So to do that, from langchain dot tools import create from tools retriever as well. Retriever import create retrieval tool. So it will create a retrieval tool. So what in retrieval tool will pass as a retriever, which we already created here, retriever db pdf, and apart from that some metadata. So what metadata will be there, something like that. Okay, you have to see search. This is a history book, and you have to. It contains all the history of Europe and the India. And for the particular PDF, it will be for this particular on the website. It will say, okay, this is a documentation of Python class. Okay, so let me show you how to do that. Create retrieval tool, retriever PDF, and the name would be history book. So always remember that you won't be able to use space here in the name. You can only use alphanumeric and underscore here. Okay, and after that some metadata about description. So it contains all the history of Europe and India 1800s and 1900s for class 10th. So a basic metadata you should give so that it decide on based on the metadata and the name whether to use this particular tool or not. So let me give a name, tool PDF. Similarly, tool web would be there. Create retriever tool, retriever web. Name would be Python documentation. Okay, then it contains the documentation of classes in Python. Okay, so some metadata you have to give always. So this can be sufficient here. So let's try to run this. It will take some time as it will split all the PDF and put into the database. Okay. Meanwhile, okay, did not find OpenAI key. Okay. Okay. Okay, here we have missed something. Yeah. So dot from documents. Since we are passing documents here, so we have to use from documents here as well. Okay. So it will take some time. Let us go to the next cell then. Let runs. So what we have done is we have created a retriever which retrieves the data and from the database, and we have also stored in here. Okay. Okay. So now what we'll do is we will combine all these. So what we have three tools here. One is from PDF, one is from website, and one other is from Wikipedia. So what our order would be: first you have to search from PDF, then website, then if you don't find in these two, then you search to Wikipedia. Okay, so I'll do is wiki. Here we have used wiki. Yeah. So what I'll query will search into PDF, then to website, then Wikipedia. Okay, so I have assigned the order here. After assigning the order, we will use chat open API here from langchain OpenAI import chat OpenAI. Okay, So what it will do is it is a core LLM here. We will pass whole the retrieve data along with your query to the LLM here. You can use Hugging Face as well. So chat OpenAI. Okay, model name would be let's model name GPT 3.5 Turbo. Okay, and you can also set temperature here. So let's assign temperature. So temperature is basically creativity. How much creative, how much different answers you want. So we don't want different answers. We want some comparatively similar, same kind of answers. Okay, so it will call. Okay, so it has come successfully called here. So now what we have to download a prompt. You can also create your own prompt, but for this particular scenario simplicity, we will be downloading the prompt from Hub. So there is a LangChain Hub here. From LangChain import Hub, and from Hub we will be pulling HW chase. Okay. HW chase 17 slash OpenAI functions agent. So this is name. So you can use different prompt, custom prompt as well. So this should run. Okay. It will download that. It will take a few seconds. It will run. After that, now we have taken all that. Now we will be combining all these. Okay. So and these things are called agents. So these are agents whether to decide which particular tool you want to use. So for here we are using from LangChain dot agents import create OpenAI functions agent. So we will be assigning all this. Apart from that, this will be creating, and we need a function to execute these particular agents. So we will be using agent executor here. Okay. After that, we will be creating an agent, create OpenAI functions, using tools equal to tools, how much tools you want, and after that we need LLM here, which is already used here. Okay, we are not defined into this LLM equal to this LLM, and prompt equal to prompt. So this will be the agent here, and after that we need to execute, right? So and before that we need an output parser as well to give simplest output. Like it can be during what agent do is it gives us the source as well. For this particular scenario, we don't want any source right as of now. We just want the answers. So we will be using an output parser here. So from LangChain dot core LangChain core, I guess core, yeah, dot output parsers import str output parser. We are using str output parser. You can use different parser as well here. Okay, so let's define it as output parser as str output parser. Okay, after that let us execute this agent executor. Let us put it in this variable here, agent executor, and what we'll do is we will first write agent equal to agent. After that tools equal to tools, how many tools we are using, and to see the output, like where it is taking output here. So we will be using verbose equal to true here, and output parser equal to output parser. So this is the output parser, and we have put it in the agent executor. Okay, so what it will do is it will execute the particular agent and it will give us the answer. Okay, so this is done. After that, what we'll have to do is so for front end, I'm using a simple framework called Streamline. What it will do is it will create a simple front end here. So import Streamlit as st. Okay, and after that, as give me some title as RAG with multi source PDF. We have given the file title. Then we have to take the input from the user. So input text st dot take input text input write your. It's just like a Python function. Okay, nothing. If an input has been passed, then what to do is we have to invoke this. So here we use the term called invoke. Okay, so our output would be stored in this agent executor dot invoke. We will be using input and input text. Okay, so we will be using this, and after that we have to print the output, right? So st dot write output. So what output will return? It will return an dictionary with input as your input portion and output as your the answer which is LLM has given. So we'll be using as output. Okay. So this has been done. Okay. So now to see this particular thing, if it is running out, we need to convert this into a py file. Okay. See, we need to run this. So let us convert this into the py file. For this, there is a function called Jupyter nb convert to script session dot ipynb. So any ipynb name, okay, it will convert this into the py file, this whole notebook. So it will take some time to run this, and yeah, it has been done, and you can see. So always make sure that you just remove this particular code which you have written, right? So it will give an error. Okay, so we will just save this, and to run this particular thing we need to for first time it will take some time. Streamlit run session dot py. Make sure that environment has been set up. So it will, what it will do, it will run into the browser here. Let's see if any error is there. It will take some time to deploy. So okay, see, the already has been done. So let's say, what is nationalism in class 10th, or what you can say, what is French Revolution Okay, so if I go to this particular PDF, so it has been talking about French Revolution starting the rise of nationalism, and yeah, the French Revolution, the idea of nation. So in this particular thing, it is all talking about French Revolution. So ideally, it should capture this particular thing. It will take some time to run. Okay, see it's here you can see the way you have put verbose equal true, right? So here we can see that all that has been taking the context from the particular book, and yeah. So similarly, it has captured this particular thing. In 1789, France, as you would remember, full-fledged, something like that. It has taken from that and summarized it basically here. So apart from that, what we can search anything as well from what is classes in Python. So here also you can see that history book we have named, so it was taking the values from the history book here as well with the query French Revolution, just querying this particular in the PDF, right? Okay, so yeah, classes in Python, so it is capturing from that particular thing. Let's say here, okay, there is too much documentation here. So Python documentation, it is fetching from the Python documentation here. So if I'll take another example of, let's say, which is not present in the Python, it's not into Python, not related to history as well. So what is, let's say, machine learning, or machine learning, let's say, what is RAG. So ideally it should take from the Wikipedia, so it will take some time, but you get the overall idea, right? So how we have to we can create a RAG with multi-source PDF here. And here you can see always the output, which is from where it is taking the generated. So since we have used verbose equal to true here, right? This verbose equal to it will get, see, it is searching Wikipedia here with the query RAG. So since it is not able to find the Python documentation, not able to find Python notebook, Python PDF, so therefore, yeah. So since maybe Wikipedia doesn't contain the RAG as well, so it will try to do, it will, I couldn't find any information on RAG, so similar like that. So this is the whole idea of RAG, of multi-source PDF, Wikipedia and LLM and all.